Ladies and gentlemen, a warm welcome and good morning to today's webinar with the topic Peak Performance for AI Excellence. My name is Toby Vuitton. I have the pleasure to be your host today. And as you can hear it, we are in English today because our expert is English speaking, sitting in Amsterdam right now. And of course, she is looking forward to meet you and to teach you more about Micron Technology. First of all, I would like to give you a small introduction of our speaker and a small appetizer. So now we have the opportunity to see her with a picture. This is Esther Spanier, Director of Channel Business Development from Micron Technology. And Esther is going to teach us more about the SSD and DRAM technology for AI-centric workloads. And I know that she will give us the answer to the question, how can you achieve the maximum of your performance with artificial intelligence? So before we are going to start, some very important informations, because today you can win. During the presentation from Esther, you can see some numbers in the slides. And if your attention is great and on 100%, you can count these numbers and give us the total at the end of the webinar. And if you count it right, you can win one of 3 high quality SSDs from Micron Technology. So please pay your attention on the slides, of course, on the expertise from Esther, and then you can win at the end. So I would like to give you some informations before we are going to start with Esther. The webinar today's will be about 30 minutes plus the Q&A session. And of course, you have the opportunity to write your questions through the chat function to us. And at the end of the webinar, Esther will answer your questions. Then, of course, the webinar will be recorded. You can find it on YouTube, for example, or on the Thomas-Krenn website. And we would like to welcome you at the end for a small survey. Please let us know, how do you like the webinar? What are the topics you are interested in the next few days or month? And of course, please write your number you counted during the presentation. And now it's time to open the stage and to broadcast to Amsterdam today. Welcome, Esther.
Morning.
Good morning. Or should I say, goedemorgen?
Goedemorgen. Yes, I'm
Yes,
impressed. Guten Morgen. I can also say that. I think we're,
great.
international all over here. But
Yes,
good
you are.
morning. Thank you so much for having me. It is a pleasure to be here.
Thank you so much for your time. And now the stage is yours. I'm looking
Oh,
forward on your presentation.
all right. Let me share my screen and then we can get going. Tell me if you can see my
Yes,
screen.
we can see
All
it.
right.
Perfect.
Okay. Fantastic. Of course, thank you all for joining today. I really hope that I'm going to give you, some new information, some things to think about when we're looking at the future of our data center. More and more AI will start to appear in those data centers, and what is the hardware that we need to incorporate into those data centers to ensure that it will all work at the best performance and so that we can get the best results. So what I am going to speak about today is I'm going to give you a few words about Micron, the company that I work for, just to give you a flavor of who we are and what we do. But very quickly, I will jump into some of the trends that are happening on the enterprise SSD side, as well as on the enterprise DRAM side. Both of those will, obviously have changes going around so that we can enable more and more, AI and high performance in these data centers. So before we start, as Tobias mentioned, you have the ability to win some of these crucial SSDs. The intent is that we're going to show you throughout the presentation some numbers. Please write those numbers down and add them up. And at the end of the presentation, whoever is able to answer the fastest with the correct answer, of course, will be able to win one of these SSDs. So, for example, on the first slide, I showed you what it's going to look like. You see here on the top right, the number 3. There will be more of these sprinkled throughout the presentation. And so make sure that you're keeping track of them and add them up so that in the end we can get, see who has paid the most attention and then also is able to win one of these SSDs. So let's get started. Some updates or kind of introduction on Micron. Micron is an American company. We've been around for 45 years. We are really a very global company. We're located in 17 different countries, and in 11 of those we have manufacturing sites and labs. Overall 44,000 people that work for the company, and last year our revenue was $25 billion. So a very, very large semiconductor that I am working for. One of the things that is not so known about Micron is the huge investment we do in technology and innovation. We have an astounding 57,000 patents on our name throughout the history of the company that we gathered. This picture that you're seeing here on the right hand, on the top part of the slide, you see kind of a wall with all these panels and these kind of little, white pieces of text. Each of these pieces of text basically represents the name of a patent holder, the name of the patent, and the number. And so you can see that this wall actually is going on for quite a long time. I was there 2 weeks ago, and it's it keeps on growing every time I go to our headquarters. And so the innovation that is going on in this company is just really, really amazing. We are working, we're bringing to the market a variety of memory and storage products, but the products that we're focusing on today are the DRAM modules and solid state drives, but we also provide other products into the automotive market, into the mobile market, into the industrial market, and so there is into the consumer market. There's a lot of different market segments that Micron focuses on, but the products and the talk we have today is specifically focused on those products that are going into a server in the data center. We are also investing heavily in the future of our company. We pledge to invest $150 billion in the next 10 years to develop new products and build new manufacturing sites. We have manufacturing sites all over the world, but we are building some new manufacturing sites in the United States with the help of the United States government through some of the funding that's been around. And so we're building additional manufacturing sites in Idaho, which is where our headquarters is. We're building a large manufacturing site in New York. We're starting that once we have all of the paperwork done. And then in Manassas, Virginia, we already had a manufacturing site, and we're kind of modernizing that fab so that we can start manufacturing there some of the newer products as well. So lots and lots of kind of manufacturing work going on in the United States, a shift away from the traditional Far East China-based manufacturing as a result of all the geopolitical tension that's been going on between the two countries, Micron decided to mitigate the business risk. It is important that we, also have some of our manufacturing, at a different continent altogether, and not in the Far East. All right, so that was just a few words on the on the company. We'll move on to the industry trends, specifically what's going on the SSD side, and what you can expect from the SSD technology in the next few years. So first of all, it's all about AI. When we're looking at the amount of servers that are shipping in the industry that are dedicated to AI, it's growing fast. Last year, according to one of our analysts that we work with, TrendForce, the global shipment for AI grew 41.5%, whereas the traditional servers was just 1.9%. So all of the products that you will see coming out of vendors that are providing products that go into a server, they're all more and more optimized for AI specific workloads, and that includes Micron as well. So when we're looking at AI from a storage and memory perspective, we focus really on three things when it comes to the design of our products. Of course, we need to have performance. You need to run these large language models so that you can keep your GPUs available and basically working all the time. So that means that both your memory and your storage need to be able to work at the highest performance. Capacity. As we're building these AI models and these AI engines, we're going to have to crunch a lot of data, and that data needs to be stored somewhere, and needs to be going into your memory to be crunched eventually. So the higher the capacity, the better it is for your AI environment. And then the last thing, that when we're looking at our design, energy efficiency, the amount of hardware that goes into a data center that is needed to create all of these AI models are, they demand a lot of energy. Data centers are increasingly becoming, a very, power hungry beast, if you will, in the overall global scheme. And so creating products that are as energy efficient as they can be is really one of the main design criteria for Micron for their products. So when we're looking on the SSD space and we're thinking about increasing the performance so that we can meet these performance hungry workloads, the first thing that that really is happening is that we are transitioning from PCIe Gen 4 to PCIe Gen 5, since PCIe Gen 5 basically enables double the performance over PCIe Gen 4. And so that really, of course, makes a lot of sense that we're, just going to go to the next generation of PCIe products or NVMe products that can double that performance. But in addition, with the transition from PCIe Gen 4 to Gen 5 and then eventually Gen 6, we are also starting to see a transition to different form factors. So in the past, the industry has been used to U.2 drives primarily when we're talking about NVMe drives, and sometimes M.2, but there's new form factors that are going to become more and more prevalent on the market as a result of the switch to Gen 5 and eventually to Gen 6. And I want to kind of explain to you why that is happening, and so that you can have a better understanding of the trends that are going on. So there's some new form factors that have been introduced a while ago. The E1 form factor has been around for a while. You may know this as the Intel ruler. but the E3 form factor is a new form factor that has been introduced with the Gen 5 generation, and it is replacing the U.2 form factor. So why did the industry come out with a new form factor? It kind of looks, very, similar to the U.2 form factor, but it kind of has a slightly different connector. The connector is sticking out. And so what is the reason that the industry is moving on to this new form factor? So the primary reason is that the E3 and E1 power specifications are different and higher than our traditional M.2 and U.2. And so when we're looking at the AI workload and we're moving from PCIe Gen 4 to Gen 5 and eventually to Gen 6 products, in order to enable these higher capacities, these higher performances that these drives need to be, working at, you need to give these drives more and more power. And you can just simply not accomplish that with the maximum power that a U.2 drive is able to get. So 25 watt is the maximum power consumption that a U.2, U.3 drive can take. You see that the E3 drive can go up to 70 watts, in the most extreme form. We are not seeing yet 70 watt drives on the market, but once we're going to go to PCIe Gen 6, we certainly will start seeing that class of drives becoming available in the market. My assumption is that right now the E3.S 40 watts will kind of replace the U.2, but that is still a jump from 25 watts to 40 watt, and that enables higher performance that is required for AI. So the transition that we're starting to see from Gen 4 to Gen 5 is that U.2, U.3 will continue one more generation in Gen 5, but once we were to move to Gen 6, we will not be seeing any more U.2 drives in the market. We will only stay with E1 and E3. We also will not continue anymore with M.2 products in the Gen 5 generation. And so these are all changes that are happening as we're moving to higher and higher performance drives, and therefore are moving to these new form factors that are enabling these performance requirements. So when we're looking at the other thing, just to give you a little bit more detail, is the E3 and E1, they can basically have different kind of connectors so that you can have different performance capability. You can have a PCIe by 4, a PCIe by 8, and a PCIe by 16 connector, and that of course allows us to have different tiers of performance that we can get out of these drives. Now in the PCIe Gen 5 generation, you will only see the PCIe by 4 and by 8. I have not seen a by 16 drive on the market. My guesstimation will be that will follow once we move to PCIe Gen 6, which is another 2 years or so from now. But this is the future of form factors in the SSD space, going forward. When we're looking at the Micron products, we have a new product coming out that is a high performance NVMe drive that is available in these 3 form factors. You see U.2, E1.S, and E3 form factors that are available today, and we are supporting those 3 form factors. When we're looking at this 9550, it is the highest performing drive in the market, and that really is kind of for those workloads where it's about getting the peak performance out of your drive. at the same time doing it in the most energy efficient way, so that we can, try to optimize as much as we can the power consumption that we are using. So then I'm going to skip this slide. The 9550, which is our high-end drive, is available up to 30 terabyte. It is our highest performer, and basically, if you want the Ferrari of SSDs, then this is the particular product that you would use from Micron. We compared ourselves to, of course, some of our direct competitors. We see Samsung and Kioxia as our immediate competitors. We did a comparison on, kind of all the metrics for read and write, and how do we measure up. And, we are, in most of the categories, substantially better than our competition, which is always, of course, a very nice thing to mention. We also looked at the AI workloads. And so, because a synthetic benchmark is one thing, but really running things in an AI workload, it is starting to make a lot more sense. So we looked at 4 different AI workloads: graph neural network training, 3D medical imaging training, large language model inference, and NVIDIA GPU direct storage. And without going into too many details, in all of these scenarios, we had better performance, and we had, lower energy usage to reach that performance. So, more energy efficient and better performance. And of course, that is one of the things that we continue to strive for when we are designing our SSD products. The other thing that is important to understand is that when you're building an AI workload, and I have many customers, they're starting to use this new NVIDIA GB200 platform. The SSDs that can be used on that GB200 platform have to be on the recommended vendor list from NVIDIA. And so the 9550, as well as some of our other drives, are on that recommended vendor list. And if you're, looking at implementing a GB200 platform, make sure that you're only using those drives that are, approved by NVIDIA. The next class of products that we have that is also a PCIe Gen 5 and is also available in these 3 different form factors, so E1, E3, and U.2. This is our very high capacity 6550, goes up to 60 terabyte in performance. It is really meant for AI workloads that need to crunch a lot of data, so you can store a lot of data that you can read very fast from the drive, and thereby, keep your GPUs fed at all times. So the idea is really, it is a capacity storage for data lakes, whereby you store, all of your data that eventually need to be crunched into your AI training, and, to create these AI models. When you're doing that on an SSD versus, we've been doing that on hard disk drives, we can, obviously do it a lot faster. We make sure that the GPUs in these training servers are not sitting idle because the data that is coming from the storage devices would take too long if we were to use hard disk drives. So the 6550, so 60 terabyte of capacity, would really be a very good solution if you're starting to work on an infrastructure that is building AI training servers, whereby you need to keep your GPUs, running all the time. I'm going to jump over this. So the competition in this field is, also the typical, names: Solidigm, Samsung, Western Digital. Also here, we looked at, all of the different metrics from a read-write perspective. And also here, the 6550 is a very, very strong product across the board. So we feel very confident that also this next, this second Gen 5 product that we have brought to the market is very, very competitive and really is meant for, that kind of, high capacity data storage, whereby, it's all about getting that data out of that drive as fast as possible. Um, then when we're looking at the entire portfolio from Micron, so we have 3 NVMe drives. The 9550, that's the high performance one. That is a Gen 5 that I mentioned before. The high capacity, the 6550, going up to 60 terabytes, will be launching in March, April timeframe. The mainstream NVMe, that is kind of our most popular NVMe drive, will be replaced in the near future by a Gen 5 product as well, as you can imagine. And then the SATA drive is still a product that we continue to support, as there is still SATA demand out there in the market. I doubt that it will be used in any AI environment, but there is still a lot of legacy, server models in the market that can use an upgrade from a SATA drive. So we will continue to support SATA for as long as the market requires this. Okay, so when we're moving on to the DRAM technology, also here the trends are to, more performance and more capacity. And so we need, more cores from a performance perspective in our CPUs. If we have more cores, we need more bandwidth. And if we're going to go to higher capacity, then each of these cores need to have more DRAM capacity sitting behind it. And so also here, that is the trend that we're seeing in, in this world. So the amount of cores that we are going to, see in our CPUs is just growing and growing and growing. And that means that the bandwidth, the memory bandwidth that sits behind these cores need to increase to keep the same amount of gigabytes per second per core. So the trend that we're seeing in the industry is that the platforms that are being brought out will demand higher and higher performance from the DRAM products that are being put into these platforms. So we're 4800 based DRAMs. We're now transitioning to 5600 and even to 6400 based DRAM product to keep up with this higher and higher demand in terms of more and more cores are being put into these platforms, and therefore we need to have higher and higher bandwidth in our DRAM products, both from Intel and AMD. You're seeing that, right? We're starting to already move to 6400 based platforms that can take DDR5 6400 megatransfers per second. And so the Micron products that we have brought to market, we are already fully released with our 6400 megatransfers per second product in all the different configurations, RDIMMs, ECC-UDIMM, ECC-SODIMM. So we now have the full portfolio available to support any of these newer platforms that demand higher bandwidth. So when we're looking at the transition from a Micron perspective of where have we sold the majority of our products in the last the last 8 quarters, 4800 speed has been really popular. In the last 4 quarters we started to transition to 5600 speed. In the meantime, we have end-of-lifed the 4800 based products, and we also brought recently the 6400 based products into our portfolio. And so you're seeing that in the last quarter. By the way, we think in fiscal quarters, so that's why it looks a little bit off to calendar quarters. But in the last quarter, you see that we started to already ship some 6400 based products into the market. And we'll see that trend continuing, that both 5600 and 6400 will start to increase in terms of the amount of products that we're shipping, since we have end-of-lifed our 4800 based products with a last time ship in July of this year. So we're looking at all of the different 6400 products here. We have brought to market all of the binary products are available already now, and all the non-binary products, so 24, 48, and 96 gigabyte, will be released in April. But then here you have also all the part numbers that are coming to market in the near future. Then we also have a new product category called MRDIMM. And MRDIMM is in essence the same as a regular standard RDIMM, but it is a multiplexed RDIMM. And by multiplexing the different ranks, we are able to get to higher performance. And by building a higher form factor, we are also able to get to higher capacity points. So this new MRDIMM is really meant for those applications that are looking for the absolute best performance and the absolute highest capacity. So HPC workloads, high performance computing, where it's all about performance, could potentially benefit from an MRDIMM. Of course, AI inference, could, or AI, even the modeling, the training of AI, when you're looking at very high performance, 8800 megatransfers per second, and up to 256 gigabyte capacity, they could really benefit from that as well. A virtual environment, so where you have many virtual machines running on a physical server. If you have more capacity, more memory capacity, and higher performance memory, then you could potentially put more virtual machines onto that server. And that means that instead of having to buy an additional server, you now basically were able to get more work out of your server just by upgrading to a higher performer and higher capacity DRAM. And then last but not least, financial services, where when you think about high frequency trading, it's all about performance, as well as latency. So these are the kind of applications when we're thinking about this new category of product, MRDIMM, where they potentially would fit. So what is an MRDIMM? Well, it looks and it feels very similar like a standard RDIMM. It has the same electrical and mechanical interface as a standard RDIMM, but we have multiplexed the two ranks of memory ranks that are on the board, so that we can access these two ranks simultaneously. So we have each rank 4400 megatransfers per second. We can access it now simultaneously, and so it gives us a speed of 8800 megatransfers per second. And so it is basically the next step up in terms of the performance. We have, standard RDIMMs go up to 6400 speed. We now have the ability to go up to 8800 speed, with these new MRDIMMs. So it looks and feels the same as an RDIMM. It just provides a better, a higher performance tier than a standard RDIMM. It also provides lower latency, very important when you're looking at these high frequency trading applications where it's all about the latency. When we're looking at the configurations that Micron is bringing to the market, we will have released already 32 and 64 gigabyte parts that are 8800 speed, and we will in April add additional capacity points, 96 gigabyte, 128 gigabyte, and 256 gigabyte will come to the market in this 8800 speed. And this is where you see these kind of tall form factor, which is kind of double the size, if you will, as a standard RDIMM that will come to the market. so that we we can get to these very, very high capacity points, all the way up to 256 gigabyte modules with 8800 speed. And so when we're looking now at all of the entire portfolio that Micron provides on the DRAM side, there really is quite a lot of configurations, but we're basically providing, from 16 gigabyte all the way up to 256 gigabyte, the different form factors: RDIMM, MRDIMM, ECC-UDIMM, ECC-SODIMM, and then ranging from 4800 speed now all the way up to 8800 speed. And so that is, a lot of different flavors and configurations that, you can choose from to optimize your hardware infrastructure. We also have, and we're getting closer towards the end of the presentation, we have some new web pages that we released recently, whereby the ODMs that we're working with in Taiwan to get all of our products qualified at their platform, we now have a separate page where you can actually go to and see which of the Micron products are qualified at these different platforms, from Giga Computing, ASRock, ASUS, etc. There is a, you basically go to micron.com/partners, and then you will find a link to this page. And then last but not least, we are also at CloudFest in 3 weeks from now, in booth G21, G23. I will also be speaking at CloudFest. So if you are there, feel free to come and meet with us, and I'm happy to meet with you and answer any additional questions you may have about memory, storage, AI, and the future of all of this technology in the coming few years. And with that, I want to thank you for all your time listening to me. My email is on this page, but I'm opening it up to any Q&A questions right now. Back to you, Tobias.
Thank you so much, Esther. So let's have a look into the chat. We got the first answers concerning the game. So now it's your opportunity, ladies and gentlemen, to ask your question. And of course, I would like maybe to help the community with my first question, because Esther, last week I had the opportunity to host the e-commerce expo in Berlin. It was a great and international event, and some speakers were talking about AI, of course, and they talked about energy that is required for AI. So what is your opinion concerning energy, or regarding energy? What is maybe important to improve the technology, that you have not the requirement of such a great amount of energy?
Yeah, so there is no question that AI workloads and AI hardware will demand more energy than traditional, than traditional data centers. One of the trends, of course, that you're seeing is that a lot of data centers are moving to colder regions, so they don't have to, spend time or spend energy on cooling the equipment. That's a big trend. But yeah, trying to do whatever you have to run in your workloads and be as energy efficiency as you can is important. That is one of the major design criteria that Micron is doing. Having said that, though, the overall power draw from an AI data center will be bigger than a traditional data center. You just have to continuing to try to optimize, to do more with less. But at the end of the day, the whole pie is still a lot bigger than what it was. So, green energy is becoming important. Moving it to colder regions, so we don't have to spend energy on cooling. Those are all becoming, more and more important as the power grid is limited, and data centers don't necessarily get more power. So they're going to have to be as efficient as they can with what they have.
Thank you so much. And maybe for you, for your question, it's easier to write it in German. It's no problem. I can just translate it or use Google if I need to. So if you have any questions and you would like to write it in German, no worries. But right now we got no questions for the moment. Maybe I can use the moment to make some advertises for the next webinars. Esther, just give us
Sure.
2 minutes and maybe there will be a question in the next moments. So maybe we can show the next slide concerning the next webinar. It will be on the 12th of March. And now I'm going to continue in German. Also meine Damen und Herren, wenn Sie am 12. März noch nichts Besseres vorhaben, möchten wir Sie herzlich einladen zum Thema Zukunft gestalten. Es wird wieder über KI gehen, also AI, Data Center und auch Nachhaltigkeit. Wir haben dann die Ehre, mit einem Herren von der Firma Horizon zu sprechen und die Vision von Horizon dann auch kennenzulernen. Grundsätzlich empfehle ich auch immer, hier den QR-Code einmal abzuscannen und auf dem Laufenden zu sein. Das ist letztendlich der QR-Code auch für den monatlichen Newsletter. So we got no questions, Esther. I'm sorry for that, but I can tell you
No problem.
the people stayed the whole time. So it's a good sign. And of course, I would like to thank you once again. Maybe you have one or two last words, and then I'm going to end the webinar.
Yeah, I mean, my last word is, of course, good luck with your design. If you have any questions on, what memory or storage device would make sense in your system, please feel free to reach out to me. I hope you were able to copy my email, but I'm sure that the Thomas-Krenn team will send that out. I'm always happy to answer any questions. Get on a call, and maybe we'll meet each other at the CloudFest in a few weeks.
Great. Thank you so much. And now we got one comment in the chat. He would like to thank you so much, and he's impressed how far Micron is with its technology. So thanks a lot. He's writing in German, of course, and just wanted to let you know, Esther. Thank you so much
Okay,
for
well,
your
that's
time.
yeah, yes.
Great. And for
Hang
your
on, how are we
expertise.
doing this? How are we doing the giveaways?
Yeah,
Are
it
we
will be afterwards because the people
okay?
have the opportunity to write their number after the webinar, and
Okay,
we will let you know.
okay, understood. Okay, great.
Great. Dankjewel,
Thank you.
and have a great
Thank you so
week.
much. You too. Bye bye.
Bye bye. Thank you.